Emostel.
Hello, this is Emmanuel Kadri and you are welcome to Emostel Academy. In this video, I will be continuing from where I stopped in the previous topic on the laws of indices. All right, so here, the first law or the first rule says x raised to power 0 is equal to 1. What it's just trying to tell us is that any number or any letter, anything raised to power 0 in mathematics is generally equal to 1. It doesn't matter what it is. So, which means if I say A raised to power 0 is 1, B raised to power 0 is 1, 10 or 100 raised to power 0 is 1. If I say 1 million raised to power 0 is 1, be it a letter or a number, anything whatsoever raised to power 0 is equal to 1. Have that at the back of your mind always, okay? Now, that is for the first one, for 0 exponents. Now, the second one, which is the unit exponent. Unit in mathematics means 1. So whenever you hear unit or unity, simply means 1, okay? So if you have any number or any alphabet or anything raised to power 1 in mathematics, it simply means that stuff is the same as that stuff. Okay, so Emmanuel raised to power 1 is Emmanuel. Okay, phone raised to power 1 is phone. So 10,000 raised to power 1 is 10,000. Anything raised to power 1 is that thing. So, but the most important part of this, or the most applicable part of it in mathematics, is the general ideology, the knowledge of the fact that when something is just there, and it's not carrying any power, you should know at the back of your mind that it is raised to power 1. And so if I say 2, if I say something like x multiplied by x raised to power 3, the answer is x raised to power 4. You know why? Because we have x can still be assumed to be x raised to power 1, then multiplied by what? X raised to power 3. So at the end of the day, we apply the product rule by saying a common base, okay, a single x raised to power 1 plus 3, which gives us x raised to power 4. Okay, so the knowledge of the fact that when a number or an alphabet, okay, like a variable, is standing alone, even when there is nothing written on top, we should always understand the fact that it is raised to power 1. It has an invisible one there. So, which is applicable whenever we are performing calculations. Okay, good. So, the next one says any variable or any number raised to power minus that has a negative power. So, we apply this rule there. Okay, so let me just quickly show you that. Okay, so if you have something like 2 raised to power minus 3, for instance, 2 raised to power minus 3, the answer, they call this one negative exponents. Okay, negative exponents. Whenever we have a negative exponent, it's going to result to 1 over the base multiplied by that power. Okay, so which means that we remove the negative exponents and have this. I'm going to explain to you how this came to be. So which simply means the final answer here would be 2 raised to power 3, that's, 8, 1 over 8. And that is it for that. Okay, but if you have something like, the next rule is just trying to explain that if you have, instead of a negative power, you have a fractional power. So if you have a situation where we have a fractional power, so what do we do? So if you have this like x raised to power m over n, okay, let me give you an example. Let's say 2, let's say 4 raised to power 1 over 2, 4 raised to power half. 4 raised to power half, because it's a fractional power, you apply the law by saying the denominator will form a root. So this denominator here forms a root, and the numerator forms the power or the exponent. So whenever we have a power, okay, that is fractional, we are going to have the denominator of that power forming a root and the numerator of that power forming a power over the new base, over the base. So which means it's going to give us like 4 as the base, okay? Then we have 2. So that's the square root of everything here raised to power 1. So which means the 1 at the numerator forms a power, and then the 2 at the denominator forms a root. Okay, so we know that any number raised to power 1 is that number. And then square root is the same thing as writing just the roots. Okay, which means we can ignore these two. Root starts from 2 upwards. Okay, there's nothing like one root. Root starts from square roots upwards. So we can have square roots, cube roots. We can have cube roots, we can have the fourth roots, and so on and so forth. But the minimum is the square root. So it starts from square root. So since it is a square root and this 2 is the minimum, we can do without it, without writing it. So when you see just this symbol, you know that it is square root. But when it is a cube root, from cube root upward, you begin to write the value there. Okay. So in this case now, it's just the square root. So we have the square root of 4, and then the square root of 4 is 2. Square root of a number simply means we are looking for a number that will multiply itself twice to give us this number under the umbrella. Okay, so which happens to be 2, because 2 times 2 gives us 4. So if we say the square root of 16, the square root of 16 means I am looking for a number that will multiply itself twice to give me 16. And that number happens to be 4, because 4 times 4 gives us 16. So the square root is just like, okay, a number like the reverse of the square, because 4 squared is 16. So the reverse is square root of 16 will give us 4. So 4 raised to power 2 is 16. Then the square root of 16 gives us 4. Okay, so it's just the reverse of the square. And so that's that as for that. So if we say cube root, then, if, for instance, what is the cube root of 9? 27. The cube root of 27 is 3, because 3 is a number that will multiply itself 3 times to give us 27. All right, so that's how it goes. So let's just take one more example on this fractional exponents. Okay, so if you have this way, please, if you are watching this video and you need to just take some notes, you can always pause the video, take the notes, then move on. All right, so we have this one saying like just the same law. Let's say we have 27 raised to power 2 over 3. You want to find the results of 27 raised to power 2 over 3. It's very simple. Okay, remember that the denominator will form the roots, while the numerator forms the power over the base. Okay, so we are going to write out the base, which is 27, and then you have the cube roots. This 3 goes here, then this 2 here comes as the power. Okay, so like this, and then at the end we have, you can choose to first find the cube root of 27 before you square it. It's even better that way than you squaring 27, then finding the cube root of that square. So it is faster for you. You get the same answer either ways you choose to do it. You're going to get the same answer, trust me. Okay, but instead of instead of having a big value first, it's good to simplify to a smaller value. Then you now power that small value, which means you find the cube root of 27. The cube root of 27 is 3, because 3 is the number that multiplies itself 3 times to give us 27. 3 times 3 is 9, 9 times 3 is 27. So after getting the cube root of 27, then you now square the results based on this. So now 3 raised to power 2 will now give you 9. So 9 is the answer. So if you like, you can say 27 squared, that is 27 times 27, get the big result, then find the cube root of that big result. It still will end up as 9. So however you have chosen to do it, you're still going to get the same answer. Do you understand that? So that is that as per that. Okay, so then one more example under this. What if we have a situation where we have something like 4 okay, 8 over 27, and then we have minus 2 over 3. 8 over 27 minus, then raised to power negative 2 over 3. So how do you solve this kind of question? Well, it's still very simple. Don't be afraid of it, of the look. So the first step is that we get rid of this negative stuff, this negative sign. So to get rid of this negative sign, you're going to apply this law, this number 3 here, okay, which says that remove the negative sign, make it positive, but the result is going to be the reciprocal of the power of the base. Reciprocal of the power of the base. Reciprocal means 1 over something, right? Okay, good. So which means we take this minus off, and then it's going to give us 27 over 8, which means the reciprocal of 8 over 27 is 27 over 8. That is, they will switch. I'm going to explain that shortly. So we have 27 over 8, then raised power 2 over 3. So that's what we are going to have. Okay, but before I proceed with this step, let me just quickly explain to you how 8 over 27 changed to 27 over 8. Now, remember the law of indices says that x raised power minus m is equal to 1 over x raised power m, right? So which means that to remove this negative sign, we are going to have the reciprocal of the base raised power, the positive power, okay, raised to the positive power. So that's exactly what we did here. What we did is that 8 over 27, so we have it as 1 over 8 over 27, okay? That is the reciprocal of 8 over 27. So the whole of 8 over 27 is the base, just like this x here. Okay, so the way we have it as 1 over x raised power m is the way we are having it as 1 over the whole of this is representing that x. That is 8 over 27, but everything raised to power what? 2 over 3. So that's how it is. Okay, now as you have it this way, mathematics says that a law in mathematics says 1 over a divided by b, okay, which is the same thing as 1 divided by a over b. If you agree with me, this division is what I brought out here. This division is what I brought out in this way. And then this 1 is this 1 here. Then 1 divided by a over b, 1 divided by a over b. I've not changed anything but just the sign. Okay, now what to do here next is 1 is the same as 1 divided by 1, if you agree. 1 divided by 1 is still 1. So when anything is standing alone, it can still be agreed that its stuff is being divided by 1 because it's the same thing. So instead of writing ordinary 1, I wrote 1 divided by 1 so that I can complement the fraction on the right-hand side. Okay? So we now have divided by a over b, right? I'm just taking it step by step so you can understand how it happened. Then we have 1 over 1. Okay, in mathematics, when division changes to multiplication, okay, the denominator will go up as the numerator, while the numerator goes down. Okay, I have an explanation for all these things, but it's going to make this video longer. Okay, but well, if you really want to get down to all of this, how they came to be, you can always contact me. Okay, so you join our tutorial, and then you can contact me from there or any of our instructors. Okay, so then we have 1 over 1 times b over a. Okay, and so which means I have changed this division to multiplication by taking this b up and this a down. All right, mathematically acceptable. Then 1 times b is b, and then 1 times a is a. So simply speaking in mathematics, 1 divided by a over b is the same thing as b over a, period. Okay, and that is exactly what happened here. So 1 divided by 8 over 27 is simply the same thing as 27 over 8, period. So which means that 1 divided by any fraction will make the denominator go up and then the numerator go down. And that is what exactly we have here. So we have been able to deal with this negative sign, okay, from this reciprocal law. And then as we have it this way, this has gone up and this gone down. Then the next thing is to apply this law number 4. The law number 4 says that x raised power m over n means that the denominator will go as a root, while the numerator goes as a power. So we are going to do exactly that now by saying, let me just take this one off. So I'm going to do that now. So we say 27, so it now becomes 27, okay, over 8, the cube root, and then that is this 3 goes as a root, then this 2 goes as power, okay? Okay, or you can also apply the law of indices like the one we did in the previous video, where we have the power distributed itself across the numerator and denominator. So you can still do it that way too. You can still do it that way, like 27, 2 over 3 divided by 8, 2 over 3. Very, very much allowed. Okay, so as you have it this way, this can also give you that same concept by cube root of 27 raised power 2 divided by cube root of 8 raised power 3, which means the denominator goes to form a root while the numerator forms a power. Then here too, denominator forms a root, numerator forms power. Sorry, this is meant to be 2, power 2. Okay, so you can choose to do it this way, or you can still do it this way too. Either way is correct, which means that here, you choose to find the cube root of 27. The cube root of 27 is actually 3. And then the cube root of 8 is 2. Cube root means we are looking for the number that will multiply itself 3 times to give us 27. You can use your calculator to find it. And then you can also use off calculator. So 3 is a number that multiplies itself 3 times to give us 27. 2 is a number that multiplies itself 3 times to give us 8. And then we have this 3 over 2. Then all squared. So you apply the law of indices, it means 3 squared over 2 squared, and then that will give us 9 over 4. Okay? Then if you choose to take this route, the cube root of 27 is 3, then raised power 2. The cube root of 8 is 2, then raised power 2. This power 2 that's out here, so the cube root is gone. So 3 times 3 is 9, 2 times 2 is 4. That means 3 raised power 2 is 9, that is 3 multiplying itself twice. And then 2 raised power 2 is 4, that is 2 multiplying itself twice. Okay, so it's that simple. The question can look complex. All you just need to do is to have an understanding of the laws and then how to apply them. That's just it. It could come tricky, it could come in any way. But knowing the laws and the application of the law, knowing where to apply a particular law or rule, just saves a whole lot of things and keeps you getting it right. Okay, so fine. Let's just quickly check out how to deal with this case number 5. Okay, case number 5 has 2 parts. A part where we have equal base but different powers, and then a case where we have different base but equal powers. Okay, so what are we going to have, or what are we going to do in that kind of situation? Okay, let's just quickly check it out. If we have this, for instance, maybe the question says 25 minus, okay, let's say the question says x squared minus 25 is equal to, or x squared minus 22 is equal to 3, something like that. And then I just have to create this question, find the value of x using the laws of indices. Okay, so if you want to solve this question, I just quickly create this question in order to establish this kind of scenario. Okay, so just watch what I'm going to do. Okay, so if we have it this way, that x squared minus 22. You can just take this one, collect like terms, send the 22 to the other side. So this was negative 22, so it's going to be positive 22 now, right? So then that means x squared is equal to 3 plus 22, that's 25. Okay? Now, what you're going to have here, you just say, okay, 25 is the same thing as 5 raised to power 2, right? You just try to establish a case whereby you're having the same power. Okay, so if x squared is equal to 25, you can say x squared is equal to 5 squared. All right. So if you have x squared as 5 squared, so which means in this case now, like this example now is dealing with this situation where you have different base, but the same power. Okay, it's dealing with this scenario too here. Different base, the same power. So 25, the square root of 25 is 5. So which means 25 is the same thing as 5 squared, right? So 5 raised to power 2, that's 5 times 5 is 25. So having the same power, if the powers are the same, it means the base, if like we have equality, it only happens when we have equality. So whenever we have equality and only one term and one term here, like this, okay, or one stuff like that, or even it could even be a group of terms, but having the same power overall. So whenever we have this kind of situation, so in as much as we have a single power overall on one side and a single power overall on the other side of the equation, and then you have, and the two powers are the same, automatically the base in mathematically, the bases are also confirmed to be the same. So since they have the same power, just say x is equal to 5. What is the proof? They have the same power. So it goes with this one, that is equal power rule. The first one here is equal base rule, a situation where they have the same base, but probably different powers, then we equate them, all right? So that's that as for that. So since they have the same base, and then if you want to solve this question the other way around, now, if you don't want to use indices, you say x squared is equal to 25. So which means that x is equal to plus or minus the square root of 25. That is, it leaves this place as power, it goes to the other side as root. Just like minus left here, 22 left here as negative, it goes to the other side as positive. So if it was multiplying to, it goes to the other side as division. Then if it was a power to, it goes to the other side as root. So mathematically speaking, when a term mathematically operating in a particular with a particular operator, whether addition, subtraction, multiplication, or experimentation, by the time it goes to the other side, it goes and acts with the direct opposite of that initial operation. So if it was plus before, by the time it goes to the other side, it becomes minus. If it was minus before, it goes to the other side as plus. If it was multiplication, it goes to the other side as division. It was exponential, it goes to the other side as root. And if it was root, it goes to the other side as exponent. You understand? So that's just how mathematics is. Whenever it crosses equality, whenever a term crosses the equality, then it goes to feature with the opposite of the initial operator. Okay, so operators can be addition, subtraction, multiplication, exponentiation, division, and all that. Okay, so now that is the aspect. So if it's find the period of 25, so you say x is equal to plus or minus 5. The square root of 25 is plus or minus 5. But because most of the time we're always interested in the positive answer, so that's why we just say, okay, x is equal to 5. But mathematically, ideally, it's meant to be plus or minus 5, which means x is equal to positive 5 or negative 5, because when you square each of them, you are going to get 25. So that is positive 5 is 5 raised to power 2, is 25. Negative 5 raised to power 2 also, that's minus 5 times minus 5. Minus times minus is plus, and then 5 times 5 is 25. So it still gives you positive 25. So which means the square root of positive 25 has two possible answers. Positive 25, positive 5 or negative 5, okay? So that's that. It's just mathematics. I just use this one to prove to you that we are not wrong. We'll still get the same 5 at the answer. Only that in this case, we are most concerned with the positive. We are just focused on the positive result and not the negative. Okay? If you want to solve this, still simple. You can have the question come in different ways. If you just know what you're doing, you get the same answer. Get it right. Okay, I can as well send this square to the other side as a root, but I'm not interested. I just want to solve it using the laws of indices. So if you have that, in as much as it's a single power, hovering around this whole expression on this side, you could as well make the two of them to be the same power. So you can have something like 2 plus x is equal to 2 plus x all squared is equal to so 5 raised power 2. So since the two powers are the same, just by applying this, it means automatically that 2 plus x is equal to 5. So if 2 plus x is equal to 5, it means x is equal to 5. This is positive 2. By the time it goes to the other side, it crosses this equality to the other side. It becomes negative 2. So at the end of the day, x is equal to 5 minus 2, which is 3. All right. So, and then if you want to prove whether this is correct, if you insert this 3 here, that's 2 plus x has 3, right? 2 plus 3, that makes it 5. 5 raised power 2 is truly 25. You see that? So mathematics don't lie. I just created this example just to let you know that we could have some kind of crazy pictures. It can come in different kind of ways, but however it comes, if you just stick to the rule and then you picture it in the simplest forms, in the form of the rules, you are always going to get the correct answer. Okay, so the next thing here is to consider a case where we have the same base and a case where we have the same base and probably different power, and then we want to equate them so we can get that m is equal to n. All right, 9x squared is equal to 144. 9x squared is 144. All right, now to solve this, okay, if you want to solve it using indices like find x using the rules or the laws of indices, okay, you can apply any other mathematical stuff that can go, but because I'm teaching indices, I want to use the laws of indices to solve this question. Okay, so you have 9x squared. You can easily change 9x squared to something like 3 raised power 2, which is 9, right? Multiplied by x raised power 2. In advanced mathematics, dots means multiplication in these kinds of cases, okay? So we have 3 raised power 2 multiplied by x raised power 2. So I just try to split the two of them, but they are still, together as with multiplication. Then this one, 44, can be like 12 raised power 2. Okay, so I'm just trying to create a scenario where they will all have the same power. Okay, now in the laws of indices, remember that law which says x times y all raised power m is the same as x raised power m multiplied by y raised power m. So which simply means that this power can distribute itself across 2 or more numbers that are multiplying each other. The same thing is applicable for division too. So now this case, I want to reverse it. I'm doing it in such a way that instead of like we having x times y all raised power m is equal to x raised power m, y raised power m, okay? I'm doing the reverse so that 3 raised power 2 multiplied by x raised power 2 will be like 3 times x, okay, all raised power 2, just like this. So I did it from here to here instead of like this, okay? I reversed it. Since they are equal, so it's the same thing. Okay, so we have instead of us to have 3 raised power 2 times x raised power 2, we are having 3x all raised power 2, then is equal to 12 raised power 2. So in this case now, all right, we are having the same power but different base, just like this, just like the same power, different base as we have it here. Okay, what I was trying to achieve is a case whereby we have the same base and different power. Well, and different power. Okay, it's achievable. It's achievable. Okay, let's just quickly solve this question. Then I'll create another question that goes that way. All right, so we have this 3x squared. Um, we have 3x, the powers we go, 3x then equal to 12. So x is equal to 12 divided by 3. And 3 and x we're multiplying. So by the time 3 goes to the other side, it goes as division. So 12x is equal to 12 divided by 3, and then that is 4. Okay? Or you can just say divide both sides by 3, just to eliminate it. So now I want to create an example to which this law can be applied. So we're looking at a case whereby if x raised power m is equal to x raised power n, then m is equal to n. That is to say, if the base is equal, then the powers are also equal. All right. So this one is for it. The other one was equal powers, different base. So then, which states that the base is equal because the powers are equal. Okay, the bases are equal because the powers are equal. Here we say the powers are equal because the bases are equal. So the reverse. That's what we are dealing with in this case. All right. So let's say we have a question that says maybe 49. Let's say maybe 7 m plus 2 is equal to 49 raised power x minus 1, or something like this. Okay, if you have this kind of case, no problem, it's still fine. To solve this question, all you just need to do is just find a way to make the two bases equal. As you can see that 49 is also 49 is like a multiple of 7. Like 7 times 7 is 49. Okay? All right, so we can just say, instead of writing 49, we can change it to 7. We say 7 raised power x plus 2 is equal to, here we can say 7 raised power 2. That is 7 times, 49 is same as 7 raised power 2. So 7 raised power 2 on its own, then we put this original power there, which is x minus 1, which is fine. All right? Now, you repeat this one, 7x plus 2 is equal to, now you remember that law that says, that law in the previous video that indicates power of a power, that power of a power rule that says if you have a raised power, or maybe if you have x raised to power m, then with another power outside is the same thing as x raised power, the two powers multiplying as m times n. So that law is what we are going to apply here. So we have 7, then these two will multiply this power outside, okay? So we are going to assume that there is a bracket here. So we say 2 times x will give you 2x, then 2 times minus 1 will give you minus 2. Okay, that's plus times minus is minus, 2 times 1 is 2. All right, now we have a situation where the two powers are now, the two bases are equal. So we have equal base now. So as we have equal base, they can cancel out, and then we bring these powers down as x plus 2 is equal to 2x minus 2. All right, so if you have it that way, you can collect like terms. Collecting like terms means the stuff that look like each other, just bring them together. So we're going to take this one to the other side. So we have this x originally here, then 2x, it was positive. By the time it crosses equality to the other side, it becomes negative. So we have minus 2x, then this equality is here. Then we have minus 2, this minus 2 that was here before. Then this plus 2, take it to the other side, it becomes negative because it was positive here. So we have it as minus 2. So x minus 2x will give you, like, I'm having 1x, but I'm owing 2x. So if I pay, then it means I'm owing 1x, then equal to, if I owe 2 and I owe another 2, altogether I'm owing 4. Because in mathematics, minus means owing, plus means having. Excuse me. And then, so since the two sides are negative, you can just cancel out, minus cancels minus. So x is equal to 4. So that is that for that. So you can see that in this case now we make sure that we have equal base, we cut them out, then we equate the powers, and then we got here. Okay, so it's quite a journey so far. I believe we've learned a lot. All right, so, and with all of this, we come to the end of this topic, laws of indices.